let's switch over here. We're all good. This session is hack-proofing your Microsoft ASP.NET Web Forms MVC applications. My name is Adam Tuliper. I'm a software architect with a company called Sejadim. And what I want to do for you today is help you empower yourselves to defend your applications against hackers. There are many hackers out there. If you ever looked at your firewall logs or you've heard it from your administrators, if you have any public-facing sites, there are attacks going on virtually every second against them. There are kids all over the world, could be adults too, they call them script kiddies. They're people who download other people's programs, they click a button, and they try to hack your program. So what we're going to do is try to give you some tools and techniques to defend your applications. As usually security is not necessarily the platform's job. They provide tools to help you in the platform, but it's really ultimately up to the developer to make sure that they incorporate these tools into their applications. And we're all guilty of leaving our applications open at different times. And I'll show you some of the techniques that we use to test that our applications are vulnerable. And they're the same things that hackers will do on the net to try to break your applications. This applies to public-facing applications. This applies to your internal applications. People don't generally think of internal hacking a big problem, so they're a little bit more lax in their security. But somebody could be sniffing your network. It could be internal espionage. I know it's a big term, but it happens. Somebody could just work at the company and want to get some passwords. So the way that this talk is going to be centered is we're going to describe each main attack. We're going to show you how this attack works. I have a broken application, an MVC application, and a web forms application. And then we're going to go ahead and exploit those vulnerabilities. And then we're going to try to fix our poor vulnerable application so it's happy at the end of the day. And see this little kind of ugly button there. I'm not a graphics designer, so forgive me for any of these graphics. The pages are ugly. I wanted to try to show you exactly what they would look like if you did a basic template website on your own. But really, the click to hack reminds me of those that was easy buttons, because that's a lot of these programs are out there now. People generally, they click a button and thousands of websites across the internet are enumerated. They try to attack them with techniques like SQL injection. So we're going to go ahead and try some of these attacks on our apps. The first one we're going to talk about is SQL injection. Now, a bunch of these are definitely very common attacks. There's a website I'll show you at the end where they list the top 10 attacks from 2010. These are pulled from some of that list. SQL injection, in my opinion, is the fastest way for an attacker to get into your system. They can exploit something on the outside and get completely inside your network. They can steal your data, create accounts. There are exploits out there where you can copy an entire database over port 80. Very dangerous. And it's such a simple attack. Now, control code in SQL injection is injected into the data channel. And people say, well, what's control code? The bottom query there, select star from users, or username, we think of that as control code. That does something. It controls something. That is our command. Mary in this query would be an example of our data channel. This is something a user might enter in on a web page or some data we're going to search on. Well, what happens if instead of entering Mary, an attacker goes ahead and enters in a closing quote, and they enter delete from users and -- which would essentially comment out the rest of your query. That would form the query we see in red at the bottom here, which really is two separate commands, completely valid SQL. It would select the results, and then separately would delete every user in the database. So it's very simple and very dangerous. We'll look at the application here in a second, but just to talk about how this is exploited, there are multiple ways. We'll go over one here specifically. That is altering the URI, and I'm sorry, we're going to do parameter tampering here, but it's just as easy to attack the parameters as shown in the first example there. Parameter tampering on a web page is very easy. One attack vector people generally don't think about a lot is to protect their cookies. What happens if you store data in there, maybe a user's ID or maybe a default search language to use in your database? They can just as easily attack those cookies, insert data in there, and change the results that are executed on your server. So there are many different attack vectors, different ways people can execute this. And a lot of these, there are scripts out there on the internet that do all of this automatically. So let's look at some examples here. I apologize for the flash. I have to show you my desktop because I just learned about these Visual Studio 2010 wallpapers. You know, you think hacking, okay, we got to protect it, we got to make it look mean. And Got the Visual Studio symbol here, and skull and crossbones. I love it. So we look at this generic application here. It's a really basic search page. We can go in here and search for anything that contains an A. We've got 3 buttons here, and we'll look at each way that this queries the database. Search bad with a normal query works just fine. Anything that has an A in it, we see all of our results turned back. Dog collars with skulls and crossbones. I guess that's the theme of the day. But I also have very foofy looking dogs, so I need dog collars with skull and crossbones to make them look tougher. If I go ahead and say, give me gold, this is just a basic search, it would return the results as you would expect. I have tracing turned on this web page. Can everybody see this okay in the back? Yeah? Up, okay. Tracing's turned on here, and I'm emitting out the query. You can see it's very simple. Select name, description, and keywords from the product table, where the name contains gold or keywords has gold. Very easy. Open quote, close quote. Well, let's go ahead and mess with this query a little bit. We put in a quote. We get an error. Something about the mod operator. Let's scroll down and see. Well, now our query here, rather than containing something inside of 2 quotes, we've now broken out of those quotes, and we have a mod operator there. It doesn't see that as a like operator anymore, which is now it's an invalid query. So an attacker would see a page like this come back and think, all right, your application is likely vulnerable to SQL injection. The second step that would probably happen is an attacker will come in and say, let's try to inject some basic command that's very, doesn't affect anything in your database. In this case, there's a wait for delay command built in the SQL server. So we'll say, go ahead and wait for 5 seconds. 1, 2, 3, 4. I wish I could do this to myself. It would kind of make those compile times a lot easier. Okay, we've got our results back. It took 5 seconds to come back. We know this application is definitely vulnerable to SQL injection. We see we successfully closed off that query and ran a completely separate query, and then commented out everything else that followed that. Let's get a little bit more inventive with that, because surely people just don't want to put delays in your database. We see that there's 3 fields returned. Let's go ahead and try to join these results with 111. Attackers use 1 because it can be converted to all sorts of different data types. When you put a quote around it, SQL Server will convert it to a number. If it's string, it works as string data. So let's search bad on this guy, and we see we were able to inject 111 into our search results. For an attacker, this looks great, because then they can get more inventive and say, all right, well, how about I join in the results, and I query every single table in your database and put it in the grid with all of your products. So we're selecting from sysobjects where type equals u, which is give me all the tables. And we look at, we've got our search results, and now the attacker knows the name of all the tables in your database. So that's one of the main steps in enumeration, but that's not enough. They say that's boring. They have an intent here where they want to look at something in your database, so they're going to get all the columns and tables from your database and say, go ahead and give me in a nice pretty grid that the developer's taken the time to develop here. And now look at that. We've got address that belongs to a customer table, city, customer ID, and oh my God, a default credit card number, which definitely would look very appealing to an attacker, and they probably won't even look further. They'll just come up here and say, all right, let's go ahead and union with all the credit card numbers in the database. And they search bad, and now they've got credit card numbers back. It's very difficult to identify this attack because these are just valid queries. They're not causing issues in your database. So what causes these? If we look over at the code, this uses inline SQL. Inline SQL means we just have a string literal, and we're packing all of our data together. We don't care what's in it. We don't care if anybody tries to escape out. And this happens a lot. So right now we're just taking our strings, using string.format, and putting our search text right in here. And we saw that if you start including quotes, you can break out of these data channels. This is expected data, but we are able to inject actual commands inside of here. So one easy way to fix this is to whitelist your data and simply say, all right, in this case, I'm only going to allow regular expressions. Compile and Adam.sleep for a little bit. Okay, now we're good. Let's go ahead and search bad. Nothing gets returned. So that issue is fixed, but that's not enough. If you have to deal with dynamic SQL, it's one way to clean your data, but dynamic SQL is bad. So let's look at a better way of doing that. And that is a technique called parameterized queries. Notice here, we have these same string literals, but instead of putting in our data from our web page directly with a string.format, inserting it directly into our query here, we have a parameter called @productName. And we're telling our SQL command to go ahead and add a parameter called product name and give it our search text from the web page. This will automatically do the proper encoding behind the scenes to make sure everything is escaped and SQL Server really understands that this is just data coming into your query. If we search better, this was our parameterized query. Nothing happens when we do that, and we should get our expected results when we just do a normal search. Now, ORMs like Entity Framework, which give you such great and easy ways to develop your application and quickly bring data access layers online. They use parameterized queries. That's how they're able to get such dynamic querying and execution on the back end. It's very powerful. It's not dynamic SQL, but they use parameterized queries. They form a dynamic statement with parameters embedded inside of it to make that safe for you. A third option here is using stored procedures. I call that search best. There could be some conjecture whether that's the same or not as using parameterized queries. It's really a preference. The thing with parameterized queries is you need explicit table permissions to select from every single table in your database. If you use stored procedures, you don't have to secure the tables. You can just apply security to the stored procedure, and a person must go through that stored procedure and cannot query your database outside of those procedures. So this here just simply calls a stored procedure called proc_search_product, and we see that we add the parameters the exact same way that we did using our parameterized query. And this gives us our results. We can't break out of this. We try to pass in a quote, nothing happens. Now with MVC, when you have items like this in a combo box and these values get posted, what happens if somebody messes with your combo box values? And this could be a sort order in your query, which was definitely used in our search bad. We see order by whatever was in that combo box. In MVC, there are no checks against this data. You must check this data on the server side by whitelisting it to make sure that whatever you enter in that combo box is valid. So here, we have something called sort orders, which I have ascending and descending. Those are the values get displayed on the page. What we do is when our data posts back, we make sure that this sort parameter was inside of that list. If not, we throw an exception. In MVC, you need to do those checks explicitly. One of the cool things with web forms that's both good and bad at times is it will check this data for you. It puts all of this data into your view state, ascending and descending. And when you post your data back, if there's a value in that combo box that didn't exist when that page was created, you're going to get an exception. So that's one good built-in protection. But it also increases the size of your view state. So in preventing SQL injection, we saw that you can easily do it by making all of your calls parameterized, which means you can call a parameterized query or a stored procedure. Stay away from dynamic strings. They will get you in trouble. We also saw that we can just simply escape or whitelist our input through regular expressions and the demo that we had with ascending and descending sort order. Another thing you want to do is audit your table permissions. Maybe your application is perfect and you say, no script kiddies, you're not going to get into my database. What happens if there's another developer developing against your database and they're able to use SQL injection in that application to get into your database? So you really want to audit your table permissions. How do you do that? I've got a query that I'll load up here. There are two other queries as part of this demo if you download the code. We probably won't have time to go into them today. If we do, we'll get to them at the end. I have two examples on better ways to do dynamic SQL. And let me load these up for you. So there's a query that will be attached for all the code for download here called permission checker. And you don't have to follow too much what the code's doing. I'll explain it. We're executing this as a user in a database, so we're impersonating the user Mary. This was as of 2000, SQL 2005 and greater, I believe. So this code's going to execute as Mary and say, give me all of the permissions using this built-in function in the SQL server for all of our tables. Then, give me all the permissions for our stored procedures. Then, 2 extra checks I like to do. Anything that has XP command shell I consider very dangerous. That allows command line queries execution to happen through SQL. And that can be very dangerous. Attackers can do all sorts of enumeration in your network and run commands. So I want to show any procedures that have that, as well as anything that has SP_execute SQL. So we go ahead and run this. We see that Mary has select permission, select, that's good. But now I see here on application user, she can update, insert, delete, take ownership. Well, these are different permissions than the other selects, so this lets me know I might have an issue I want to look into. This user should only have select permissions on all these tables. Next, I see that the stored procedure, 2 execute permissions here, and to me that's fine. Those are no problem. At the end of our data, proc_get all users, that had a problem based on the rules that we've defined here for showing these, so I want to go and audit those and check the permissions and see if that's using SP_execute SQL. They're just extra flags to go and look at. The 2 queries you want to look at in the demos are a very quick way to do dynamic SQL using SP_execute SQL, which allows parameterized queries. A lot of people aren't aware of that. They see SP_execute SQL, they think danger, danger, but there is a safe way to do dynamic SQL with that, and that is to pass in parameters. The other demo you can check out in the download is ways to do dynamic where clauses. And this has some cool built-in functions to do dynamic ordering, dynamic selecting, and there is no dynamic SQL in here. So check those out on the download. So you don't need dynamic SQL. There are ways around it, a lot of ways around it. We talked about you can whitelist everything possible, use parameterized queries. SP_execute SQL I mentioned can use parameters. The command exec does not allow you to use parameters, so stay away from exec as well. Now here's some quick misconceptions with SQL injection. You are not always safe if you use stored procedures because you could have dynamic SQL in those stored procedures that an attacker could pass commands into. Someone asked me, well, if I replace only -- in a quote, I'm safe then. And that's not always true either because you might be only querying numeric data, which doesn't require a quote and a --. There's ways to form your query that you don't need a --. Now, if you have an error page, it helps prevent attackers from getting valuable information when they try to do SQL injection. But it doesn't of itself make you safe. We saw that we can still inject delays and find out if your site is vulnerable to SQL injection. Proper permissions won't always protect you because you might allow all the users to have select permissions in your database. But if somebody is able to use SQL injection to query your entire database, then they were able to bypass these proper permissions or use these proper permissions to query your entire database. And parameterized queries will potentially protect you. It depends on how you use them. Again, they generally require you to have select permissions on those particular tables. So you just have to audit those permissions and make sure they're correct. All those things together that we've looked at help make your application safer. If you implement them all, if you get away from dynamic SQL, you will be safe against SQL injection. But it just depends on the varying level. You might have stored procedures that a DBA uses. You don't always have access to change everything. So you can only do the best that you can in your application to help prevent these attacks. The next attack that we'll talk about here is called cross-site scripting. And cross-site scripting is a very easy attack, but it's very, 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 very dangerous. So let's look at what it is here. Basically, you can describe it as JavaScript is executed on a web page that somebody didn't intend for it to execute. It can get in there because somebody else puts it into the page, they get it in the database that then displays on the page. Somebody might be able to get it on a cookie. Somebody could pass it to you in a URL that they get you to execute. There are 2 types of this attack, reflected and persistent. A reflected cross-site scripting attack is one that generally happens, say, on your URL. You run it and data on your URL gets executed in your page. That's reflected. It comes right back to you. The other type is persistent. For instance, if somebody goes to a blog engine and they store evil JavaScript into the database, that would be a persistent attack. It's always there for each request. It's persistent. With this attack, somebody can access the DOM. They can steal cookies, do all sorts of crazy stuff. We'll look at a neat demo of that. So evil script is somehow injected into a page. A happy user comes. They visit the page. And I have a happy face and a sad face there because you don't know a lot of times if you've been a victim of that. So you might just continue on with your happy day. Some people know, some people are malicious, and they pop up dialogues, and that will make you frowny. Up top on the right there, I just included some funny names. When they were trying to decide upon a name for cross-site scripting, they had some really interesting names there. Synthesized scripting, fraudulent scripting. They went through a whole bunch of them. So how is it exploited? We talked that script basically finds its way into a page. You can use all sorts of different methods to get that data to your page to execute. Some people say, well, maybe I can just have a filter. I can strip out the word script from anything that somebody posts. That alone won't stop. Cross-site scripting. If we look at that div tag there, filtering out the word script won't do anything on that. That's valid JavaScript. It doesn't require the word script. The second one there is a complicated regular expression. Internet Explorer 6 supported UTF-7 encoding that you didn't even need the braces around the less than and greater than sign around your script tag. You could do it just like that, and it would execute that as JavaScript. You don't need any script tags at all if you have them inline in attributes, as that last example there, body, onload. That's valid JavaScript. How would you filter something like that out? It's very, very difficult. So let's look at some examples of how we would exploit this. This page here, again, I'm not a designer, graphic artist, so bear with me here. These are based on the default templates that come out. This is super sweet products. We're looking at some used tires here. And you notice there's some comments in this database, and we can add our own comments. Super tires. These are awesome. My grandfather's truck has these. And we look at the bottom here. Of course, it just adds our data. So what happens with evil people that come in and they say, oh, you know what? Let's go ahead and try to inject some script in there. For brevity, I've just got some JavaScript. Nice little query here that uses jQuery and dialogues. You can check the details out of that if you want in the downloads. The important thing we'll look at here is what happens when this gets pasted to this page. So an evil attacker comes in here and they insert some JavaScript into here. It has a real header on there. This item is great, but then a bunch of malicious JavaScript. So what happens? It's been saved to the database. It shows at the bottom there, this item is great. Let's reload this page. Somebody else comes to this page, and what happens? Hey, you get prompted for authentication information. Let's go ahead and log in. The problem is, this login dialog wasn't part of this website. This was that JavaScript that I injected in there. How would the vulnerable user have any idea? If that pop-up fits the exact same theme and CSS of the site, they would never know it. This would pop up. They'd happily enter their information. That gets posted off to the attacker's site, and they have your authentication information there. And the user doesn't know about it. Luckily, to fix this, it's very, very easy. Let's go ahead and look at this product details page. And we need the web for this. Now we look at the bottom here, and we're using data binding, this guy here, and we simply are emitting out the comments. The problem is here on the page, we saw that if we look for this item is great, this is all of my injected JavaScript right there. All of this stuff. And notice, it's valid JavaScript, and we saw it was executed. To defend against this, we simply HTML encode this. Now, there's different ways that we can do this. We can call HTML encode that's built into the .NET framework. What I like doing a little bit better is using the anti-cross-site scripting library. There's some links at the end. I'll post this where you can download that, so you don't have to write that all down now. It's a little bit better HTML encoder, in my opinion, because HTML encode by itself as part of the .NET framework, is concerned with preserving HTML compatibility. Doesn't care about security, that's not his job. The HTML encoder, which is put out by Microsoft, it's a separate download, is concerned with security. And its approach is a little bit different. Rather than encoding only a certain number of characters, it uses a whitelist technique. So it basically says, I know that these few characters are safe, encode every single thing else unless I don't know about it. It supports multiple languages too, understands different languages. So let's go ahead and run this page again, and now let's see what happens. It has encoded all of our data. This is not valid JavaScript anymore, and we're protected against this. And of course, if we go back to this page as an administrator, we're going to say, oh, look at that. Somebody tried to get into my site, and I was able to defend against this simple but effective attack. Now, one thing I did on this page, to be fair, is I have validate request equals false, which normally is true on a default web page, but a lot of developers turn this off. We have these dynamic websites that allow people to enter HTML on our pages. And when we do that, we get this kind of error. Everybody's probably seen this before. If you have a less than sign in any character, ASP.NET says, this could potentially be a cross-site scripting attack, and disables it. The problem, as we saw, though, you don't always have to have a script tag to execute this. This is an additional protection, though, but a lot of people do turn this off. So defending this was simply a matter of HTML encoding. So remember, test your applications. Just insert less than and an S, and you'll see if that's enabled on your pages. Some people disable it application-wide. Very dangerous. The idea is, if you get this error, figure out why it's happening. It means your data is not getting encoded before it gets sent over, posted back to your site. This happens a lot with WYSIWYG editors on web pages. Some of them nowadays will encode that, like Telerik control will encode before it posts back to the site. So if you're looking at using a WYSIWYG editor to allow people to edit HTML on your site, look at some of the options out there that allow you to encode your data. If we look at a real quick example for the cross-site scripting library, here's a quick page. We can just insert some script in here, just like any other. Before, and we'll insert the word after with some script in between. So right there, we get some JavaScript executed on our page. If we look at the code on this, I search for before. And right here, there's our script, there's everything, it's encoded. Now watch when we use the Microsoft anti-cross-site scripting library. Instead of just spitting that text out, we'll call, one of the libraries included with it is the sanitizer library. And they've got this method on there, getSafeHTML fragment. That will try to parse it the best it can and remove anything that's malicious out of there. If we try this again, notice nothing happened now. And if we look at what happened to our malicious code that we injected, the JavaScript was completely removed from there. So in preventing this, we saw that we can HTML encode our data using the cross-site scripting, anti-cross-site scripting library. There are different ways to HTML encode your data, though. You don't have to explicitly call HTML encode. With MVC 3, which is an awesome product in my opinion, they have that @ syntax. And anything that you emit using that @ syntax automatically HTML encodes your data. Secondly, as of ASP.NET 4, you had the less than, %, and colon. That automatically HTML encodes your data as well. You can explicitly call HTML encode. You can also, for attributes that are inline, you can use HTML attribute encode. Although I highly recommend if you ever have to encode attributes, you really think about how you're doing your code, because it's very difficult to defend against cross-site scripting on HTML attributes. Now I have a warning there, that syntax with the £, unfortunately that does not HTML encode, and we use that a lot in our data binding in our web forms applications. When you're using that syntax, you should explicitly call HTML encode using the anti-cross-site scripting library or just a regular HTML encode. Avoid turning validate request equal false off. It's just an additional protection provided. With WYSIWYG editors, there are several that do support encoding. Talerk's the only one that I've worked with, but I know there are several that do. MVC 3 included an attribute that you can say on your model, allow HTML. And that will allow you to post HTML without throwing this exception. Don't set validate input equal to false. That just turns everything off. Now, another thing added with ASP.NET 4 is this runtime encoder type. And that's a really neat feature because that allows you to specify a better encoder to use. And let's look at my web config. Right here, HTTP runtime encoder type. This is using the anti-cross-site scripting library encoder. All calls to HTML encode in the application, whether it be through the syntax that I showed you before or explicit calls to HTML encode, will automatically be redirected through this library to do the HTML encoding. Now, the one caveat is they released this in 4.1. 4.1 is still in beta, so if you want to do this now, you download the source code and you compile it. Hopefully 4.1 will be released soon, but it's a simple compile. Some people say, well, how about I encode my data and then I store it in a database? I say don't do that because that can lead to double encoding. If you look at the example there, a less than sign will get encoded as ampersand less than, which then gets re-encoded upon the next save, and over and over and over. Sometimes you can see strings this long when people save their data. And I'm sure a lot of us have seen websites with data that look like that. So use that get safe HTML fragment, sanitize it, then store it in your database, and make sure that when you emit your data out, you're HTML encoding it. Another thing you want to do is test all of your controls. Go ahead and inject script. We saw that it was really easy. Do a less than sign and an S, see if that works. Inject a simple JavaScript alert and see if your controls break. Another thing that you want to know is how do all of your controls encode your data? Now, for instance, a text box in web forms will HTML encode your data. A label will not. A literal control will not. So you need to know your control's behavior to make sure that data in your database doesn't get exposed on your screen as script. There are charts out there on the internet that you can check this out, and they'll show you exactly what these, what control's behavior happens to be. Please prevent IE6. It was good in its day, but we must stop IE6. In fact, there's a funny little demo. Woo! Yeah! You're going to clap even more when you see this quick demo. Do I have internet access here? Here's one quick funny site, the IE6 countdown. They show you what parts of the world are still using Internet Explorer 6. China, come back China, is an astounding 34.6%. United States, luckily, is down to 2.4%. But that's still, roughly 2 people out of every 100 that come to your website that can have problems. And let me show you how easy it is to cause problems. I have Internet Explorer 6 running in virtual mode here. It's basically a virtual machine. Let me show you, there's a link on here to view a high-res image. This is just a link to a GIF. You can see at the bottom, 00000.gif. If we look at what that GIF contains in our images folder, let's open that with a binary editor. I've got a GIF header in there. But after the GIF header, I've got all the script in there. Internet Explorer thinks it's smarter than me when loading a file type, and it does this thing called content type sniffing. Goes into the file and looks around and says, well, you got a GIF header there, but I see all this extra script in there, so I don't think it's a GIF. I'm going to execute this as script. You load the image, and bam, JavaScript executes. And look at, this is a GIF that we loaded, so thank you, IE6. Again, let's get rid of IE6, please. IE7 up does not do that. The next attack that we're going to look at here is cross-site request forgery. This is a nifty attack, and this actually hit Twitter in 2010 and posted obscene things on everybody's pages. This uses the fact that you are authenticated on a website and somehow gets you to execute, to do a link, JavaScript, etc., to that website. It has to proxy through you, the authenticated user. The attacker crafts some sort of special request, and they try to get you to run it. It could be through an email. It could be through a blog. It could be through some product comment page like we saw before. In emails, this can be exceptionally tricky. The next slide will show you a demo of this. Identifying the attacker on this type of attack is very difficult because you, the authenticated user, are a valid user of that system. So they're hacking through you as a normal user. There's not these outside attempts that are visible in logs. This exploits the fact that taking a particular request is generally repeatable. An attacker can form a request and give it to you to repeat. Now, we've all noticed in various mail programs, images by default nowadays do not load by default. You have to click on a link to get those images to load. There's a very, 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 very good reason for that. Some people might think it's related only to bandwidth, but no. This is to help also prevent this hack attack. What happens if an attacker sends you an email, and in that email is simply an image link? It doesn't have to be a valid image. It could be, for instance, in this example here, create user Jane Doe. Well, what's going to happen is when you load that email and the images, your browser is going to send a request off to whatever the website is as you, the authenticated user, sending your cookie over with your authentication information in it, and it's going to execute that. In turn, it's not going to return a valid image. The user's not going to see anything. They're not going to know anything happened at all. This can also be attacked by cross-site scripting, the attack we looked at earlier. Maybe one of these links, maybe some of this JavaScript is posted into a blog or a site somewhere, and you execute it again. JavaScript can be very tricky, too. You can create an invisible image, as shown in the last example there, and set its source equal to a URL. You won't even know anything happens there. Let's look at some ways that this is exploited. We've got this application here that we can delete a user. I think a valid user here is 48. All right, this user was deleted. The bad thing is, all I did was simply pass this parameter in, and we've all at some point in time in our development career made applications like this. It executed this without prompting us for anything. That's the first problem. Let's look at another type of attack here. Let's load up Fiddler, which is an awesome tool. It's a debugging proxy. All the requests go through this and then back out to whatever site. We can see everything that's going on. If you're not using it, download it and use it. In this case, we're saving Bob. Hi, Bob. Bob saved. We look at the request over here and delete everything else. So here was our post request, and we can see that we passed over user ID 7 and Bob and a password. Well, what happens if somebody just tries to replay this request? We see that it executes just fine. The point of this here is that this request is repeatable over and over and over again. So the first thing that we want to try to do to prevent these attacks are to make sure that any actions, for instance, we deleted that user, goes through a post action only. That somebody just can't send you a URL that you execute. We need some sort of user interaction here. The second thing we want to do is use a hidden form token to make your request unique. Let's look at fixing both of these items here. So we'll go back to this delete user page. That was admin delete user. And rather than just having all of our code here, delete it right upon page load. Right here, we're just deleting. Let's go ahead and comment out that delete and make sure they have to go through a button. Okay, we built. Now, we try to delete the user. And we go back to adam.sleep, and we're good. Now we have prompting. delete user, whatever. So they can't send you this in an email anymore and make this happen automatically. So ASP.NET is, web forms is somewhat fixed here. We'll circle back to this in a minute. Let's go back over to our MVC application. And we want to make sure that we have a token, a unique token that gets passed in. This is included as part of the MVC framework. HTML.anti-forgery token. This generates a form field that has to be there when you post back. It's validated. Not only is the form field validated, there's information included in your cookie that has to be there as well. So an attacker just simply can't craft a little request on the URL and have you execute it. They need this token on the form. Now, there's two components to this. We need to fix this here. And in our controller, we simply need an attribute. Validate anti-forgery token. Now we notice when we load this page, there we go. Let's go ahead and let me just show you this in Firefox real quick, just because there's a cool feature in the web developer where I can show hidden form fields. Now notice we've got this form field now. This is our token. It's a hidden field and must be there on postback. If we go back and we try to replay that old request of ours, so we reissue the old request in Fiddler. Notice now we've got a 500 error. And let's go into web view, gives us a nifty little more realistic view of our application's response. We can see that the text there, a required anti-forgery token was not supplied. So this made your request more unique. It made that an attacker on the outside just can't simply get you to execute a URL. Now, let's go back to web forms because there's something really neat about this. Let's go to that slide. We saw that with MVC we can simply include anti-forgery token and validate it. One thing in web forms you want to do is do not turn off viewStateMac. That helps make sure that the data that's on this page that gets posted over has not been tampered with at all. One thing I didn't cover on MVC also, we saw in web forms we made sure that there was a user interaction there. You can specify in MVC this action can only be executed through a post method. So if the user tries to execute this request on the query string, this will not execute. This must be a postback. Which brings us to something very interesting with web forms. Hello, I'm the one-click attack. As developers, we have a lot of interesting assumptions that we thought were correct with the way that our pages work. Now, we think that button commands are only processed on postback events. They are our events after all. We think that view state is processed when we post back. That's when it's used. That is false as well. Page.is postback. Well, surely that must mean that we have a postback occurring, right? I mean, it's called page.is postback. That is false as well. And let's look at some ramifications of that. We've got my awesome graphically designed super sweet products application here. We'll create a user named Atlanta. Hey, you. The user has been created. Notice is postback equals true, which we expected. Let's go look at the code for that real quick. That was admin add user. So in our button save, which we think is happening on postback, right? We're going to create our new user. And we are simply spitting out if this page.is postback equals true. Clearly that was a postback. I agree, that was a postback. Well, let's look at messing around with this a little bit. I'll go to Fiddler and look at this request. Was this our post? This was our post request. This is what we want right here. All right. We go to text view, and we can see that our data that was sent over with a request contains our view state. It was on the form. That's what we expect so far. We have our arguments, etc., user Atlanta, and a password, hey you. Cool so far. Let's copy this text. Let me run Notepad here. And rather than Atlanta, we'll call it hacked. Now, let's actually take this URL and paste it in there. So we have our request that now looks like this. Everything is on the query string, even our data that should be sent over on the form. This is a reproduction of this whole event that we just did, this button click. That surely must require a user to be there and click that button. That's what we think anyway. Well, I'm sure you know where I'm going with this. Let's paste that request in there. And I ran it, and look what happened. Is postback is true, and our user has been created. So wait a minute. Did we just reproduce an entire user interaction on the query string? Yes. Somebody typed information and clicked the button, and we were able to duplicate that simply on the URL here. What if the attacker sent this to you as that image link? You would have just created whatever user that they want in your database. This is called the one-click attack. So because we've had all these assumptions with web forms, you're like, oh, wow, this is scary. How do we go ahead and fix this attack? This is a variant of cross-site request forgery. Fixing this is simply a matter of taking your pages and inheriting from, instead of page, I use a page-based class that I have in here you can download. And in this class, the first thing we do is make sure that a session is established. If you don't set a key in your session, the session ID changes every single time. Every single request just keeps changing. So this is going to fix the session. Secondly is we're going to sign the view state with that particular user session ID. This makes it unique to your session. If somebody gets you to execute this tomorrow, you're in a new session, that view state's invalid. If they try to use their session and send that data to you, it's valid as well. Your session ID doesn't match theirs. And I do a couple other checks in here to make sure that the view state is not on the query string, that it is indeed on the form. Let's compile this and go ahead and try to run this again. View state can't be passed on the query string, so we've been able to easily prevent this attack. It's very minimal changes to your application and stops the one-click attack. The next attack we'll talk about is parameter tampering. And it's a little easier to understand. The name is very easy. Someone's messing around with parameters. Tampering gone wild. I wanted to get cheerleaders on the stage in a cape, but they wouldn't let me, unfortunately. So this attack, it's very easy to execute and can really be dangerous to your application. And I guarantee 90+% of us, myself included, have all been guilty of this at some time, and I probably still am on occasion. The idea is that there's a key field on our web page that maybe maps to something in the database, and you write it out there, and you post back, and you use that to update your database according to that primary key. But what happens when an attacker changes that value? Well, you're now updating a different record than you expected. So let's look at a demo of what that looks like. We have that edit user page. Let's actually go back here so I can show you these hidden form fields. Edit user, Bob, hello 112. Let's find this guy in the database. This is our MVC database, DemoDB. User, show table data. Okay. We have 3 users in there, admin, Bob, and Mary. We can see the IDs here 1, 7, and 8. Let's go ahead and see what these hidden form fields look like. That was our forgery token. Okay, that can be there, that's fine. This isn't a forgery. This is parameter tampering. going to mess around with these parameters. So we're going to take Bob's ID, which is 7, and we're just going to simply make that 1 now. And we'll call this now hacked admin, and whatever. Submit. User saved. Let's go back and requery this database. Now we see user Bob, who clearly is not the administrator, was just able to completely update a record that they didn't have access to. Now, with MVC, we have these great things called model binders. They will take our data on our web page and automatically map it to a business object, so we don't have to say user.username equals text username.text over and over and over again. But it's also very easy to overlook the fact that this data from the page cannot be trusted. Do not trust this page data. There are several ways that we can validate this. This was an MVC application I showed you. One thing to note in web forms, if you tamper with these hidden values, that's part of your view state. You will get an exception when you try to post it back. The problem is some people nowadays, jQuery is getting a huge movement behind it, and you use it to change stuff on your web page. Well, if you start adding stuff to your combo boxes through jQuery and JavaScript, and you try to post these new elements back, that's not in your view state, and you're going to get an exception. So a lot of developers just turn that off. There's another alternative. You can use page.client.register for event validation. The problem with that is you have to tell it every single new value that you could potentially add to that combo box, and you don't always know that. So as such, a lot of developers turn this off and leave this open to attack. One way to prevent against this is simply check the data on the server side. The user that's currently requesting this change, do they have the same company ID of the record they're updating? Do they have the same user ID as part of their profile? So there's different ways to check against that. Another option that I like doing is in MVC, I write out a hash to the web page, and we'll look at a demo of that. I'll basically take Bob's hash of his user ID. So we're going to hash the value of 7 and create a little cryptographic hash on the web page. There's an attribute that I wrote that's on secure-coding.com, and I call it anti-model injection for user ID. What that's going to do is that's going to take the value in user ID in our current model, since we have this great strongly typed stuff in MVC. So go ahead and take that value and hash it out to the web page. When you post back, let's go ahead. Uh-oh, I just started to debug this. Hold on one second. Adam.sleep. Okay, so I'm saying when you post back, look for a hashed user ID on the page, and also look for the user ID value on the page. Hash that and compare the two. Do they match? If they don't, then we have a problem. Compile this, and let's run this guy. Now, not only do we have our request verification token from the prior step that we looked at, we now have this user ID token because we are looking for the user ID field, and here is our hash that was generated from it. In this case, it was a hash generated off of the value 7. Well, so let's go ahead and mess with this data. Actually, rather than using Firefox here, let me show you a way you can do this in Fiddler. We are going to set a breakpoint in Fiddler before requests. We're going to go ahead and submit this guy. And it's waiting for us to do something. Let's look at the values here. Let me make this a little more visible for you. Okay, we see that we've sent over these values, 7, Bob, and a password, and our tokens. Well, what happens if we try to mess with this data now? Change this to a 1. Sometimes you have to switch back and forth for it to pick it up. And let's go ahead and resume this request. Now look we've got a 500 error that comes back from this. And let's see what our error message says. Failed security validation. This is because of the attribute that we've included on here. It says these hashes don't match. There's been some sort of tampering that has gone on. And go ahead and throw up an exception. If we don't have this value, if you're not using that attribute, it's very, very, very easy for somebody to tamper with your data. We saw that all you need to do is show hidden form fields, change an ID, and you've essentially hacked that record. So preventing tampering, we saw that we can validate. One way of doing this is validating our data, making sure that the user's ID that they're editing is their own user ID. You'll have to figure out the checks to do on your own for that. That becomes difficult at times. The reason is, when you query data, you have some sort of security rules in place. You say, all right, give me the record for Bob's user ID. But then you need those same rules when you go ahead and you update that data. Well, what if those rules get out of sync? And it happens. So as an additional protection on there, make sure that your enable event validation in web form stays on. And also check out that attribute, the validate anti-model injection for that's up on my site. And that'll help you, or hash it yourself manually if you choose. The attribute just makes it a little bit easier in the MVC applications and kind of keeps that same model syntax, strongly typed. Now, when you're dealing with a web farm, some of these techniques won't always work, because if you go to server A and you generate a hash there, and then you go to server B and generate a hash, they are using different machine keys, and those hashes won't actually match. If you hash 7 here and 7 over there, those hashes are different. There are a lot of articles on the net on how to get your machines and web farms synced up together, and it just involves using the same machine key across each of your machines in the environment, and then the hashes will be the same. Encryption. This is not an attack. This is simply a way to help protect your applications. And it's very easy, and a lot of applications are very guilty of just not using it. Some of this, of course, is going to make common sense. You're going to look at this slide and say, well, of course we should protect sensitive config settings. But 90% plus of the applications I see in the web config, you open it up and everything is in there in plain text. Happens all the time. Another thing that as well does, hash or encrypt your passwords. Yes, it's common sense. What if somebody SQL injects your database and pulls down all your passwords? It's easy to hash them. The other thing you can do is encrypt your passwords. If you're using a membership provider that's provided as part of the .NET framework, there is an option you can specify on there to hash your passwords. If for some reason you need to keep those passwords in the database, maybe because of lost or forgotten password functionality, make sure you write an encryption routine and encrypt them. There's tons of stuff out there on the net on how to do very, very basic encryption and hashing in the .NET framework. It's simply, for your hashing, it's a call to forms authentication create hash for storing config files, something like that. It's very, very basic. There are additional demos available that I have on here just to show you various methods of doing some encryption on the SQL Server side. Just so you know, these demos are here. We won't go through them right now. You can use certificate. You can create a certificate to encrypt your data. The other thing that you can do is you can encrypt with a passphrase using a customer ID or any custom field as a salt to have unique encryption for every single row in your database. So the same number encrypted for this customer is different than it is encrypted for this customer. Check out these two. It's encrypt by passphrase in the code download and encrypt by certificate. If we get done a couple of minutes earlier, we'll circle back to these. The thing that I find, since these, of course, are on database side, and a lot of times the databases are out of our control, things that we can definitely do as developers are protect our web configs. And let me show you, sometimes you forget to switch back and forth here. This was the encrypt by certificate. This was the encrypt by passphrase. Hopefully we can circle back. If not, like I said, download those. Let's look at our web config. And in here, let's find our connect strings. There those are, little buggers. What did I do here? Well, I've got plain text credentials in here. And we've all been guilty of this at some time. Don't deny it. We all know that we've done this. If not still, you know who you are. So how do we protect against this? How do we encrypt these? And it's so easy. There's no reason not to. I've got the command stored here. This is kind of neat. If nobody else knows, when you're running commands at the command line, press F7. You get a menu of your recent commands that you've run in this session. So this guy here is a Visual Studio command prompt, so it has access to ASP.NET Reg IIS. And I'm running as an administrator, so it can access my metabase. Let's run that command. I said go to the application/security and go ahead and encrypt connect strings. Simple as that, it's all done. And we come back to our web config, it's going to tell us it changed. Yes. Now notice, plain text there, drum roll. Now it's all encrypted. If somebody's able to access this file, snooping on this file, everything's encrypted. Well, you say, well, what if I need to come back to this file and my boss is asking for a login ID or something and I don't know what it is. The team 17 years ago, they were doing COBOL.NET and they changed this all up and we don't know what they're doing. You can simply come in here and just, instead of E, specify D for decrypt. D for decrypt, E for encrypt. We run this command, and we're going to see that it changes our file again. We reload it, and we're back to plain text. Now, this is very easy to protect. You should all do this. When should you do this to your applications? Not during development. You can do it during development, but when you deploy your encrypted web configs, they're not going to work on the other machine because of the same issue I talked about in web farms. Every machine has its own unique machine key. And when you encrypt stuff on it, it's specific to your machine. So what I recommend doing is once you deploy it to the server, load this up and then run it. So it's encrypted out on that server, and then you should be good to go. So as I said, encrypt after deployment. Hash or encrypt all of your sensitive information. It's very, very, very easy to do. This is another area that's just makes a lot of sense, but believe it or not, a lot of places don't do it. Sometimes they're internal applications, and people think internal applications don't need to be protected. It could be a public application. You just haven't gone through the trouble of getting an SSL cert. You should protect your entire applications using an SSL cert. There's no reason not to. If you have a very high-performance site, there are hardware solutions out there to help with speed of SSL. Protect all your internet applications. It is so easy for an attacker to steal your session by sniffing the traffic. If they're on your network, if they're sitting next to you in a cafe, and you happen to hit a session that is a login page that's not encrypted, they can just look at that data. They can scan for it. They can set a routine to look for anything that has a word password in it. Very easy for them to find this information. Various types of authentication that we use pass your information over. For instance, forms authentication tokens, basic credentials, they are sent with every single request, your username and your password. Forms authentication tokens will be in your cookies, every single request they come over. For someone to steal your session, all they need to do is get that one value, set it in their browser, and they've now hijacked your entire session. And there are so many utilities out there that people can use their wireless cards to sniff traffic. So definitely be very wary of any sites that don't have SSL certs. Request them, use them. Don't use them if they don't have SSL certs. Get them on your own sites. Now, HTTP-only cookies are one thing to implement on all of your cookies, and they prevent JavaScript from accessing those cookies. The browser will send them back and forth, but if somebody's able to get some JavaScript, for instance, like we saw through cross-site scripting, someone injects JavaScript and they're trying to steal your forms authentication token, they won't be able to, because the browser doesn't allow those cookies that are set with HTTP only to be read by JavaScript. So set that attribute on all of your cookies. Another thing to note is forms authentication has a setting you can use, require SSL. That doesn't mean force everything to be SSL on your site. What that means is only send the authentication token over if we are on a secure connection. If you are on a non-secure page, it just won't send it over. The problem is if your non-secure page requires a user to be authenticated to view it, it's going to redirect them right back to the login page, and they might get stuck in this endless loop trying to access this page. So if you just have SSL certificates protecting your site and have require SSL and make sure that every request is SSL, these users' information will be very well protected. Some sites I've seen include session information right on the URL. Somebody can simply copy that. That could be read by JavaScript and put it in the attacker's system, and they could read it. It's easy to read the current page through JavaScript. So don't put any session information when you're designing a site on the URL. It only takes that one cookie value or one session value for somebody to hijack your entire system session. The next thing we'll look at here is information leakage. What is that? Well, it's when your site gives out information that it shouldn't. And let's go over and look at some demos in a second. Let me load up a site. All right. Oh, I still got my breakpoints on. Let's turn all those off. Resume my requests. All right, that's the first one I want to show you. Let's load up some other ones. We've all seen the yellow screen of death that happened in our application here. We go ahead and we try to click on a link that's not found. We throw an exception. The exception happens in our site. The user gets information back. We saw when we did SQL injection that these errors help somebody fine-tune their attack. So what I like to do is put a little basic error page out with your application. In this case, I call it cause error. And this is how I check to make sure that my error handling is working properly in the site. In this case, we saw that both times I was able to cause an error. Let's go ahead into our web config. And turn on custom errors. And it's very easy to specify. Custom errors, mode equals on, and some default web page to go to. Now we'll save that and try to cause an error again. Hey. We don't get that same yellow screen of death here. In fact, where is my errors page? I should be getting redirected to that right now. All right, my default error page isn't loading up. Let's not look at why now. But the important thing here is to notice it attempted to go to my default error page. And the user was not given any sort of information. Normally when this is working, of course, you get redirected to a generic error page. But in this case, the attacker is not getting any information. If they try SQL injection here, they're not going to get the details of their request back. So put out a basic web page. It's very easy to turn custom errors on. Let me look at my page real quick, make sure I don't have anything silly in here. Oopsie. And my page is acting up for some reason. But anyway, turn custom errors on. And that's going to prevent those yellow screens of deaths from coming back. Now this is a funny thing too. Make sure all your tracing is disabled. It sounds like it's common sense again. We saw that on the SQL injection page. We had tracing turned on and we're able to see our SQL query there. Try to go into your applications and specify trace.axd. Try to check different, let's go back to this guy here. Oh, sorry about that. trace.axt. Let me go back in and remove my errors. And enable tracing on my site. We see that our site is going to spit out any of this information. Security will go to product details. And all of our requests are now visible to somebody who's able to get access to this page. Now, the funny thing is, all right, like I said, it seems that it's common sense to go ahead and turn this off on your site. A simple Bing search for trace information shows all of these production websites with tracing turned on. Interesting. So it's not as common sense as you might think. It's very easy to forget this. It's one step to make sure that you check for in your application. It's so easy to check for. Go to trace, look for it. Query your entire application for the word trace. See if anything comes up. I've seen trace pages out there with login credentials and everything. It's kind of crazy. Please check that. Don't submit an application. Don't publish an application out there on the internet without making sure that your tracing is turned off and your error handling is on. Here's some various tools and resources. I've included, this is a bit.ly link bundle, so it is case sensitive. bit.ly MLML1B. I've got a whole bunch of links that are posted up in there. Security links, there's a link to the anti-cross-site scripting library, Pluralsight on-demand training library. They have a free trial available. Talking with them right now about getting a security training video series out there to go into detail on a lot of the subjects here. An hour is not a huge time to go deep on these subjects, and you can go very deep on them. OWASP is a very important website to check out. They're the ones that publish the top 10 list, the Open Web Application Security Project. They have 10 vulnerabilities for 2010, and they show you in different technologies, .NET, etc., how to fix your applications against those. The Microsoft Code Analysis Tool .NET runs right now Visual Studio 2008. The 2010 version is not available yet. That will use the FXCOP rules engine to audit your application and find things like SQL injection and some other common attacks. Vulnerabilities open in your application. That's another cool tool as well. So go to that bit.ly link and check out all of those links there. Some related content. These are some other good sessions. Some of them have already happened. Since the videos are online, I think 24 hours, you can watch a bunch of these videos out there. This one will be up too. Please fill out your evaluations on the way out for me and for any of the other people that you see. It definitely helps us to come back, let us know how we're doing, where we can make ourselves better, and whether or not this content was appropriate for you. My blog is completedevelopment.blogspot.com. I blog about a whole bunch of different things out there, MVC, security, etc. Twitter is at Adam Tuliper. As mentioned, Pluralsight, there's some free training, free trial training out there. After this session, I'm going to be down in the Learning Center. They have the web platform stand there. It's next to, I think, the Expression Blend stand. If you haven't checked out the Learning Center, it's a great resource. Actually, one of the things that I like coming to Tech Ed the most about is you get to go to the people that work on these products, that develop these products, the product teams, the team managers, and say, you know what, how do I do this? How do I do this in Silverlight? How do I do this in web forms, MVC? When I'll be down there, we can talk security or anything related to web if you'd like. So check that out. It's a great resource. I think there are 4 or 5 today. It's open till. So if you have any questions, come visit me there. Here's some additional track resources. And thank you very much for coming. I hope that today you've been able to, thank you. Hopefully, I've given you some tools to really help protect your websites. This is all current technology. You can go and use these in your application today. There's nothing in the future that's coming out. This is not future technology. You can protect your applications now, so definitely implement some of that, and your applications will be in a much better spot. Thanks again, and hope you enjoy the party tonight. That should be pretty good. I think we got the aquarium, the Coca-Cola Center, and I hope to see you there. Thank you.